Welcome back to Science, everybody. So nice to see you. And thanks for showing me all the compasses that you made. Those were so great. And now today we're going to talk a little bit more about compasses and how they work and why they work. One of the amazing things about compasses is they don't need any batteries. Do you know why? Because the whole Earth is like a giant magnet. Inside the Earth, way deep underground, we have different metals. We have iron and nickel. And those are swirling and swishing around. And with all of those metals swishing around inside of the Earth, it creates what's called a magnetic field. In magnetic fields, we can't see. It's how magnets work. So at the top of the Earth, we call it the North Pole, and on the bottom of the Earth, we call it the South Pole. So when we use a compass, it always knows how to find where the North Pole is. So when we have a compass, that's why it works, because it's like a little magnet inside and it's able to float around and find that magnetic field, and it goes right to north. So then we always know where it is. So there are 3 kinds of magnets. Ready? Can you hold the 3 fingers? The first type of magnet is called a temporary magnet. And temporary just means for not so long or not forever. So that's stuff that can be a magnet for just a little while. And the second kind of magnet is called a permanent magnet. And that means that it's always a magnet and it was born that way. The third kind of magnet is an electromagnet. What? What does that mean? Well, that means it's something that can be a magnet when you hook it up to something electric. And those can be like trains that move really fast with just magnets underneath. You've seen those before. Or if you go to a big junkyard or car lot where they have those giant magnets that can lift cars, that's an electromagnet too. So now let's go look at some magnets together and learn more about how compasses work.
Okay, so we're going to look at some magnets now. So just like the North and the South Pole, magnets also have opposites. Remember, the North is at the top and the South is at the bottom, right? Like this on a compass. And then of course we have East and West, right? But with magnets, something that they always pay attention to is which way is north and which way is south. And the amazing thing about the magnets is that they are attracted to the opposite. So opposite of north is south. But is opposite north also north? Let's see, what do you think happens if we put north to north? Oh, hey, come back. Hey! All right, so look at that. North had to get to south, right? Because opposites attract with magnets. And then if we put it to south, what do you think is going to happen then? Come back, come back, come back. But do you remember when we were talking about things that were electromagnetic? That is like trains that run with magnets underneath. And that's just like this. They put the south up like this, like pretend this is the train track, and pretend this pen is the train, right? So look at this. If we put that underneath, so then the south is looking at south. Look at this. They push away from each other. I can't get it to stay. You see how it goes away? So that would be like the train tracks. And then the train can go very, very fast. So let's talk about some things that are temporary magnets. So right now, this is a type of metal called iron. An iron can be magnetic, but it's not already a magnet by itself, right? Like if I take these 2 things, they're made out of different metals. This one is kind of made out of steel, which is also kind of an iron type of metal. Look, do they stick? But if I bring it to a magnet, it is magnetic, right? And this needle, for example, is another thing that's not magnetic. Because look, does it stick? Doesn't really go. But here is another needle that I've had on top of this magnet for a long time. So when things are temporary magnets, they can hold on to magnetic charge for a while. So look at this now. If I take this one, it's a magnet temporarily. And so these magnets are an example of something that is a permanent magnet because they're just magnets all the time. And they don't lose their charge like a temporary magnet. So these are all objects that are made out of metals that can be magnetic. So we have iron. You can tell those are iron also because a lot of the time iron has red and they get dark and rusted. And this one also is made out of steel, which is a kind of iron. Nickel. And look at this. All magnetic. All right, so now we can make our own magnets at home. So do you remember I was talking to you about that temporary magnet? And this needle I put on this magnet for a while, and things that are temporary magnets, like this needle, can hold on to magnetic charge. It can borrow some of the magnet's power. And when we do that, we take it off, it can hold some of it, and then it can help us. Because you remember, where do compasses always point? Yes, they always know how to find north. So I'm going to show you how you can make your own compass at home. So this one I've left on the magnet for a while, so it's ready to go. So I'm going to put this down in here so it can float. So now I'm going to take the needle from the magnet, and remember, it's able to borrow the magnet's power. So it's going to be able to find north because it's temporarily like a magnet. So let's see which way it goes. So look at that, it found north. And I have a compass over here on a phone. You see? Look at that. Same direction. So it's able to find north. And look at this. We also know because if I turn this bowl, look what happens. And even if it gets a little bit wobbled from the water, it still can go back. I'll give it a little space because sometimes it bumps the side. You see it spinning back? And look at that! It found it again.
Isn't that stuff so cool? I love how magnets work by themselves. So now it's actually your turn. If you have a magnet at home, then you can test out some of these materials and see which things are made out of iron, nickel, or cobalt if you have it. But one thing to also remember, if you're doing this at home, make sure to keep your magnets away from anything that's electronic, like a phone or computer or TV, that kind of stuff. Make sure a grown-up knows, because the magnets can actually mess up electronics and make them not work anymore. But refrigerators are always okay. So if you have magnets at home, I'm looking forward to seeing what you find is magnetic. But if you don't have it, then share with me something that you learned today. I'm excited to see what you come up with.